could have used synthetic division for the last one that we just did. So what we're going to do is we're going to start by just looking at the last one that we just did, which was example 2. You don't have to write this down, but I just want you to watch. So here's our example 2, and that's what we got as an answer. I'm going to do the synthetic division in this little space here, so it doesn't take nearly as much room as the long division. That's why it's a shortcut. And what mathematicians did for synthetic division is they set up the following. First of all, they looked at the polynomial they're dividing, and they said, well, instead of writing x to the 4, x to the cubed, x squared, and all that every time, if we just wrote the numbers in front, so 3, -1, 0, 3, and -20. If I just wrote those numbers instead, and I spaced them in, they were in the right order, you would know this is x to the 4, x cubed, x squared, x, and your constant. Okay? Then if you're dividing by x plus 2, what we're going to do over here, instead of writing x plus 2, we're going to write minus 2 instead. So whatever is inside here, just write it with the opposite sign. The reason they do the opposite sign is because part of the place where people make mistakes when they did this was in subtracting. Because subtracting a negative, you forget a minus sign here, it's more difficult. If I make it a negative out here, what we can do is we can add instead of subtracting. And people make less mistakes when adding. So then synthetic division looks like this. You always bring down the first number. What's 3 times -2? -6. Put that -6 there and then add. -6 plus -1, -7. Do the same thing again. What's -2 times -7? 14. Add. -2 times 14? -28. Add. What's -2 times -25? +50. Add. Notice the numbers that we just got. 3x cubed minus 7x squared plus 14x minus 25 and a remainder of 30. You like that? And we're done. Well, we still have to write our division statement, but this will always be your remainder. And then this is your constant. This is 1x. This will be your x squared. This will be your x cubed. And it works very quickly. So you've watched that one. Now we can go to example 3 and do one that you can do in your notes. Okay. So same kind of setup needs to take place. Things need to be in order, and you need to have zeros if things are missing. So the biggest power is x to the 4. Notice these are already in the right order. Is there any that are missing? No. 4, then 3, then 2, then 1, then 0. So we've got, don't even have to add any zeros. So we can just start -3, then 2, then 3, then -4, then 5. We're dividing by x plus 2. So out front, we put -2. Always bring your first number down. Multiply -2 times -3, you get 6. Then add. Then you multiply -2 times the 8. -16 and add. Then you'd multiply the -2 times the -13. You'd get 26 and add. Then you'd multiply the -2 times the 22. -44 and add. Now we've got our answer. The last number is going to be a remainder. We can write our division statement. We started with -3x to the 4 plus 2x cubed plus 3x squared minus 4x plus 5. That's our polynomial. We're dividing by x plus 2. We got as an answer negative 3x cubed plus 8x squared minus 13x plus 22. And a remainder. This is our divisor, this was our quotient, and this is our remainder. So ones you can do for this are 8, 9, 11, and 12. Which method do you prefer? You are allowed to go home and learn as much math as you want. You are allowed. We forgot to stop our previous video.